Bismillahirrahmanirrahim. Assalamu alaikum students. My name is Bushra and I am here again with another lecture of chapter 7 Fundamental Principles of Organic Chemistry second year. We were discussing about the hybridization of orbitals and the shapes of molecules. We have discussed the sp3 hybridization. Today we will discuss about the sp2 hybridization. In sp2 hybridization, 1s and 2p orbitals are intermixed to give rise to hybrid orbitals. In order to explain the bonding in unsaturated compounds, two more modes of hybridization have been developed. The structure of alkenes can be explained by sp2 mode of hybridization. In this type, 1 2s and 2 2p orbitals of carbon are mixed together to give three equivalent and coplanar sp2 hybridized orbitals. In this paragraph, it is saying that in order to explain the bonding in unsaturated molecules, in unsaturated compounds which having the double and the triple bond, like the alkene. In this case, we are discussing the alkene. For alkyne, we will discuss the sp hybridization. For unsaturated sp2 hybridization, we will discuss the example of alkene as CH2 double bond CH2. Two more modes of hybridization have been developed, sp2 and sp hybridization. So in this case, in this line, it is saying that the bonding in unsaturated compounds which having a double and triple bond, two more modes of hybridization have been developed. sp2 hybridization and sp hybridization is developed. The structure of alkenes can be explained by sp2 mode of hybridization. The alkenes having the double bond, the molecules which having the double bond, the structure of those molecules which have a double bond can be explained by the sp2 hybridization. In this type, 1 2s and 2 2p orbitals of carbon are mixed together. So we will again discuss the ground state electronic configuration of carbon: 1s2, 2s2, 2px1, 2py1, 2p0, 2pz0. So carbon having the atomic number 6, then this is 1s2, 2s2, 2 to 4, 5 and 6. One of the orbital is empty. So in excited state electronic configuration, one of the electron from 2s orbital is promoted to 2pz orbital. So it is forming the four orbitals which having the 2s1, 2px1, 2py1 and 2pz1. In this mode of hybridization, sp2 hybridization, only 2s1 and 2px1 and 2py1 will intermix. 2pz1 will remain not involved in the hybridization, not involved in the intermixing of orbitals. So in this type, 1 2s and 2 2p orbitals of carbon are mixed together to give rise to three equivalent and coplanar. Coplanar means the same plane, having the same plane. sp2 hybridized orbital. So s orbital we have discussed as s orbital having a spherical shape. px orbital is draw along the long x-axis, py is y-axis. So 1s and 2p, px and py intermix to give rise to coplanar and three equivalent hybridized orbitals. This geometry is written as, okay, you can also write this one. This is equivalent and coplanar three hybridized orbitals. So each sp2 hybrid orbital is directed from the center of an equilateral triangle. This is equilateral triangle. If we draw an equilateral triangle, then this will form. So to triangle to its three corners, the bond angle between any sp2 to sp2 hybrid orbital is 120 degree. So in hybridization, you must have know about the electronic configuration of that element. You must have practice on the ground state electronic configuration of carbon, excited state electronic configuration of carbon. So after writing this electronic configuration, the next step you have to write the bond angle and the geometry of the molecule. So in this case the bond angle is 120 degree. The unhybridized orbital, which I have discussed, that this orbital remain unhybridized. This 2pz1 orbital remain unhybridized. So this unhybridized orbital, 2pz orbital, will remain perpendicular to the triangle thus formed. Will remain perpendicular. So in formation of ethene molecule. In the formation of ethene molecule, 3 sp2 orbitals of each carbon atom overlap separately with sp2 orbital of another carbon. This is the triangle. Okay, this is hybridized orbitals. This pz orbital remain perpendicular. So the hybridized orbitals of each carbon atom, this carbon and this carbon atom, this hybridized orbital form a sp2 overlap, this form sp2 s overlap, this form sp2 s overlap. Because hydrogen has only one s orbital, so this overlap is sp2 of carbon with one s of hydrogen, sp2s, and this between two carbon atom is sp2 and sp2, because both carbon atoms are sp2 hybridized. So in the formation of ethene molecule, 3 sp2 orbital of each carbon atom overlap separately with sp2 orbital of another carbon and one s orbital of two hydrogen atom to form 3 sigma bond. 1 2 3 sigma bond. 1 2 3 sigma bond. This gave rise to what is called the sigma framework of ethene molecule. Sigma framework. This sigma bond, this sigma bond, this sigma bond. For this carbon atom, this sigma bond, this sigma bond, and this sigma bond. Each carbon atom has 3 sigma bond. The unhybridized orbital of each carbon atom will then overlap in parallel way to form a pi bond. This unhybridized orbital, this overlap formation of pi bond. So that's why the pi bond is present in ethene molecule, one sigma bond and one pi bond. So this is all about the sp2 hybridization. In next lecture we will discuss the sp hybridization. Allah Hafiz.